In this topic, we shall be having a quick review of definition of a set, subset, empty set and power set. The purpose of this recall is for three reasons. One, to do a quick review of basics of set theory which is required in our topology course. Two, to familiarize with various notations which we shall be using during the course. And three, to give an introduction to some of you who may be unfamiliar with the various concepts of set theory. As I said, in this topic we are going to learn the following subtopics, that is the definition of a set, the definition of subsets, definition of empty set and the definition of power set along with some examples of these. Let us recall the definition of a set. A set is a collection of well defined distinct objects. The objects which forms the set are called as elements or members of the set. The objects can be anything like numbers, lines, trees, animals or even sets themselves. We shall use the capital letters A, B, X, Y and so on to denote the sets, and the lowercase letters small a, small b, x, y, etc. to denote the elements which belong to these sets. If an object X belongs to a set A, then we shall denote this by X with the Greek alphabet symbol epsilon, representing that the element X belongs to the set A. And if X does not belong to A, we express this by the symbol epsilon with a strike on it, denoting that X does not belong to A. The equality symbol used throughout this course actually means a logical identity. That is, when we write X equal to Y, we mean that X and Y are symbols that represent the same object. Since a set is determined by its elements, one way to write a set is to list all its elements and enclose them with curly brackets. This is called as roster method of describing a set. Let us look at the following examples. Let us look at the first example, the set of all vowels in English language. This can be written as A equal to A, E, I, O, U in curly brackets. The set of all integers, say for example strictly between 5 and 12, and we can denote this by the alphabet B as another set equal to, and the integers between 5 and 12 we know are 6, 7, 8, 9, 10 and 11. A set, as we have already discussed earlier, can be having elements as sets themselves. So, we can see the third example where the set C is having elements as a set of natural numbers, the set of integers and the set of rational numbers as its elements. Another way of writing a set is using the set builder form. A set can also be described by specifying a property or properties that is or are satisfied by the elements of that set. This is known as the set builder form. For example, consider the set A equal to elements 1, 2, 3, 4, 5. Then this set can also be written as A equal to the set of all natural numbers n such that n is strictly less than 6. So, this is how we denote the elements 1, 2, 3, 4, 5 using their property, and we know that the property which we have used is all these are natural numbers and they are less than 6. Let us look at another example, the set of all real numbers that are strictly between 2 and 3. The set denoted by 2, 3, which is an open interval, can be written in the set builder form as the set of all x in R, that is the set of all x which are real numbers, such that x is greater than 2 and x is less than 3. Let us come to what is an empty set. A set which has no elements in it is called as an empty set. It is denoted by the alphabet phi. For example, if we consider a set of learners from your class whose height is more than say 20 feet, then obviously this set is an empty set, as in a normal class you will not get anybody whose height is more than 20 feet. Or for example, we may say the set of all prime numbers which are greater than 5 and are even, and we know that the only even prime number is 2. So, this example also becomes the example of a empty set. A set is said to be a non-empty set if it has at least one element. Let us come to subset. Take an example of a set A consisting of all clothes available at a certain cloth shop, and another set B as a set of clothes that we buy from that shop. We can observe that either there are no clothes in the set B or B has some clothes. In any case, every cloth which is in B is going to be there in A. In such situation, we say that B is a subset of A. Let us look at the formal definition of a subset. We say that a set A is a subset of B if every element of A is an element of B. This we denote by this notation, and when we read it as A is a subset of B. Observe that for any set A, empty set will always be a subset of any set, and every set will be a subset of itself. These are by default to be remembered. Let us now look at the various examples of subsets. Let us take the example of set of all learners in your class. Then this set of all learners in your class is a subset of set of all learners who are enrolled in your institute, right? Take another example. Say the open interval 0 square root 2, it belongs to the set of all real numbers. Let us look at the definition of equality of two sets. Two sets A and B are said to be equal if they have same elements. That is, if A is a subset of B and B is a subset of A, we denote this as A equal to B. Now let us come to the important component of a set theory concept, which is called as the power set of a set. Given a set A, the power set of set A is the collection of all subsets of A. That means if we list down all subsets of a set A, then the collection of all those subsets together will be called as the power set of A. It is denoted by P of A. Let us take an example. If the set A has 3 elements, say A, B and C, then what will be the power set of A? As I said that in the definition of power set, it is the collection of all subsets of the set A. Why not pause the video now and take a pen and paper and list down with this example of the set A in front of you with 3 elements A, B and C, and write down all possible subsets you can for this set A. So if A is equal to A, B, C, 3 elements, then the power set will contain obviously 2 default members, that is the empty set and the set A. In addition to these 2, it will be having all singletons, that is singleton A, singleton B, singleton C, then all pairs A comma B, A comma C, B comma C, and any other possibility is left out? No. So if we see it again, this set which we have written down here is the collection of all possible subsets of the set A equal to A, B and C. So friends, in this video we have seen definition of a set, subset, empty set, power set and examples related to this. In the next video, we shall do a review of the concept of various operations which are defined on any set. Thank you.